Welcome back, Trig. This is going to be our last lesson for the week. This is going over 5.3 trig functions on any angle and what are reference angles. We're going to get at it today. We're going to go through bell work, homework quiz over the trig identities and cofunctions. So hopefully you're prepared. We're going to go through at least 3 questions on the bell work that will more than likely be on the homework quiz. Obviously, we're going to go through the objective essential question, 5.3, trig on any angle. What are reference angles? We're going to answer that, and then closure, summary, homework, so that you can start on your review tonight. We have a quiz tomorrow, basic trig functions quiz tomorrow. Okay, this is going to be your second quiz of the quarter. We have another quiz about a month from now, but this will be your second quiz for the quarter. And the reason why I'm doing the quiz, guys, is because this is foundational trig. If we don't know this, then we're not going to be able to survive in trigonometry, to be completely honest with you. Okay, so that's why I'm doing a trig. I need to make sure you know it well enough to move on. Let's get started with the bell work. These are the 3 questions that I have for you on the bell work. Okay, so use the first one, use Pythagorean identity. Obviously, they give it to you right here. Sine theta equals radical 3 all over 5. Next one, cofunction, and then next one, the calculator. So those are really the 3 things that we did on the last video. If you have yet to watch the last video, do it. Watch the last video before watching this video. So watch 5.2b identities before watching 5.3 trig on any angle. Okay? We did identities on the last video, we did cofunctions, and then we did calculator work. And that's really the summary. I have these 3. Let's get to it. How do I do this Pythagorean identity here? Well, they give us the identity, and I just want to find cosine. I don't care about the other identity or the other trig functions. I just care about cosine. Okay, so I know that this is what sine of theta equals, and I'm just going to implant that right there. So watch, radical 3 all over 5, and then squared. This is plus cosine squared theta equals 1. So I just implant that there. That squared goes to the radical 3, the numerator, and the denominator, the 5. So radical 3 squared is just 3, and then 25 squared is 5 squared is 25. This is plus cosine squared theta equals 1. I have to subtract this over to the other side to combine like terms to get cosine squared by itself, just like it's a regular variable. Just because it's a trig function doesn't mean anything. It's a regular variable. So this is cosine squared theta equals 1 minus 3 all over 25. I need to make sure I combine terms here. So I need common denominators times 25 times 25. So what does this give me? This gives me cosine squared theta equals 25 minus 3 is 22. And then all over 25. I need to square root both sides. That goes poofy. Square inverses goes poofy with the square root. I'm left with cosine theta, just like if I had x squared, I square root, that goes poofy, right? And I'm left with x. In the same way, you're left with this. Cosine is just another x. It's another variable that we need to find. And then this, of course, is radical 22, which I can't simplify, and then radical 25 on the bottom is 5. So this is cosine. Could I find the other ones? Yes, I could use the quotient identity to find the other ones, like tangent or cosecant. I can flip that and so forth, but that's not what it's asking. It only wants cosine. I found cosine. That's the end of my problem. Unicorn for good measure. Okay? Fantastic. Let's move on to the next one. So these 2 cofunctions, and then we'll get to Desmos on the calculator. So what is a cofunction? A cofunction is different than a cocaptain. That's what we talked about. So tangent's cocaptain is cotangent, or sine's cocaptain is cosecant. But here we're talking about cofunctions. Now, it just so happens that tangent's cofunction and cocaptain is cotangent. Okay, so that means this equals cotangent. Because we're using radians, I'm going to use pi all over 2, and then minus pi all over 4. Okay, pi all over 2 is like 1/2. I take away 1/4, I have 1/4 back. So if I have 50%, I take away 25%, I still have 25%. So that means my function is cotangent of pi all over 4. Now, if they asked to evaluate this, we could, okay? And this is just 1, by the way. So if we wanted to evaluate it, that's what it is. But most likely, they'll just say find the cofunction, and that is what it is, cotangent pi over 4. Okay, how do I evaluate it? You should have that in your notes from Monday's lesson of 5.2a, basic trig functions and special angles. Let's get to the calculator work. We notice that this is radians and this is cotangent. So if I'm using a TI-36X Pro, first of all, I need to change it and do the reciprocal and do it this way. If I'm using the TI-36X Pro or the TI-84 or some other old calculator, this is how I would have to actually implant it, type it into my calculator. Now, if I'm using Desmos, I don't need to do that. All I have to do is make sure it's in radians, okay? Make sure it is in radian mode. You need to make sure it's in radian mode. So what does this equal? Let's go to Desmos to find out. I'm going to put in cotangent 3 pi all over 14. So I'm going to go over here. I'm going to type in cotangent and then 3 pi and then divided by 14. And then let's check to see if we're in radian mode. We'll go over here to the graph settings. We're in degrees, so we have to press radian mode, and then boom, that's my answer. More than likely, they'll tell you to round, so we're going to round to 1.25340, okay? So it'll be 1.2540, that's 6. Makes that 9 a 10, which that 9 makes that 3 a 4, so 40, that's my answer. Okay, that is how I round. Most likely, they'll probably tell you to round to the 4th decimal place. That's why I round to the 4th decimal place. If you have any questions on that after you watch this bell work, before you get started on the homework quiz, by all means, jump onto a Google chat with me, the Google Meet link during our times, and talk about it with me. I want you guys to adequately know what you're doing before you take the homework quiz. Let's erase. Let's also erase this and get started. I'm going to allow you 25 minutes on this one because it can get sort of confusing. It is kind of brand new math. We are doing some decent trigonometry work. So I'm going to give you 25 minutes on this. Open notes, of course. You have 5 questions. Get started. Pause the video if you need to. Just remember, make sure you review your answers at the end, and make sure you send any partial credit requests to me, my email, if necessary, okay? If you forgot a negative, or you did a square root, or maybe you did divided by 1 when it really didn't want that, or you forgot your pi, anything like that, maybe you rounded wrong, anything, send it to me, and I will be the sole judge to whether or not I give that to you. If you're not going to do that or don't need to do that, and if you're solid, then begin the notes today. Remember, starting next week is going to be the optional homework quizzes, but you're still required to do the homework quizzes this week. You're still required to do the homework quizzes this week, okay? Just want to make that super, super abundantly clear. Please, please, please. Awesome. Get started on today's essential question. What are we doing? I need to get a drink. That's what I'm doing. Okay, let's start on the essential question. What is it? So 5.3, trig on any angle. I'm going to be straight with you guys. This lesson, the reason why I put Gerard Butler here is because it can get intense. I'm going to teach you a lot of stuff that it's going to be kind of hard for you to remember everything. This lesson will easily be over an hour long. I'm sorry. It is what it is. So make sure you just pay very close attention. This is very, very important. If you took Algebra 2.2 with me, quarter 3, period 1, this may sound like some review. If you remember, not all of it's review, but most of it's going to be review. So that's awesome. But if you're brand new with me, it may be, I'm just going to be honest, it may be a struggle. I'm going to do my best to teach it to you, though. I'm going to do my best. That's my job. I care about your education. That's who I am. I care about your math. I want to teach you the what, the why, the how on the math. And so I will take it very, very slow. All right. And I'll go through tons of examples, lots of checkpoints for you to check your own work. So please utilize them. How do I find an angle measure using trigonometric functions? Let's find out. Let's do this. Okay. So We haven't really done too much with the XY plane. I remember the very first day when we went through angles and radians. I told you trigonometry, we're going to start putting geometry on the XY plane. That's why we learned it in algebra, guys. We are taking algebra with geometry. Algebra is an XY plane, right? XY plane, yes? This thing right here, this Y, this X, okay, and this is my right angle. So an XY plane, we put geometry on the XY plane, and we start performing algebra on it. I mean, honestly, that's trig. I mean, trigonometry is really geometry on steroids. Okay, that's honestly what it is. And so we're going to be using a lot of triangle work, and we're going to be working with, algebraically, the XY plane. So why do I have an XY plane here? Okay, I'm going to ask you to plot the point 3, 4 on the standard Cartesian plane. That is just your XY plane. It's labeled Cartesian because Rene Descartes came up with it. Did you guys know that the XY plane is only like 500 years old? Yeah. Like Euclid, the almost a father of geometry, he had no idea what the XY plane is. Descartes, the Cartesian plane, Descartes developed it for us. Okay, so I want to point this. This is the point 3, 4. Okay, that's the point 3, 4 right there. Awesome. All right. Now, if I plot the point 3, 4 because this is 3, that's 4. Now watch. Calculate the distance between the point and the origin. How can I do that? Well, there's a couple ways to do that. Okay, this point right here, most of the time in algebra, we did this. This was 0, 0, right? And I can calculate this distance using what formula? You should all be saying, "Oh, that one formula, the distance formula." What is the distance formula? The d equals, I have this huge long radical, and then this is x2 minus x1, and then I square, and this is going to be plus, and then y2 minus y1 squared. This right here is what we call the distance formula. It should ring some bells. And I'm going to cloud that. All right. So how do I calculate this? Well, it's actually very simple. You need 2 points. We have 2 points, right? So d equals the square root. Doesn't matter which one's x2 or x1. No, as long as you're consistent. So I'm just going to start with here 0. So 0 and then 3. So minus 3 and then squared and then plus and then 0 here and then minus 4. That's my y. And then I'm going to square that. So I have the square root. 0 minus 3 is just negative 3. Squared is just 9. And this is negative 4. Squared is just 16, which reduces down to radical 25, which reduces down to 5. So what's this distance? It's actually 5. That's how you learned how to do it in geometry. This is how you also learn how to do it in algebra. How do you do it using trig? Let's find out. Watch this. What's the distance between here and here? What's this point? Well, you should say, well, the point is 3, 4. Well, watch. I went a distance of 3 here, right? And then I went a distance all the way up here of 4, right? So I went 3 over on my xy plane and then 4 above, correct? And now we can start to see, holy junk, this is a 3, 4, 5 triangle. And I'm like, yeah, okay, it is. Now watch this. You didn't need to do the distance formula. What you could have done is this. A squared plus b squared equals c squared. Right? So you could have done 3 squared plus 4 squared equals, I don't know what that is. So this is 9 plus 16. And then this is c squared, square root. Now watch. Square root 9 plus 16 is literally the exact same thing here. So what does that mean? That means the distance formula is the Pythagorean theorem. That's what it means. The distance formula is literally a derivative, or derivation. I don't even know how to say it. Derivation? Derivative. I'm just going to stick with derivative. English is not my strong suit, clearly. But the distance formula is the derivative of the Pythagorean theorem. That's what it is. Isn't that crazy? So to me, when I first learned this, I was like mind boggled. I was like, are you serious? You mean to tell me that everything in algebra basically revolves almost around geometry implicitly? Yeah. Did you know geometry came before algebra? Euclid predated Descartes, and Descartes was in the 1500s, so the 16th century, and then he died in 1654 or 1650. He was born in 1596, so he's only 54 years old, but he was the one who algebratized almost, or at least popularized the algebra of geometry. Okay, there's other people who predated him, like Islamic mathematicians and Asian mathematicians, but they weren't nearly as popular. Okay, you know why? Because they're not white. I mean, I'm gonna say it straight up as honest. Okay, they had better publishers. The Western world will always dominate the philosophy, mathematics, the theology, just the science, as it always has. Descartes was part of the Western world. Pythagoras was part of the Western world. Euclid was part of the Western world. And so whatever they do is obviously going to dominate. So Descartes basically algebratized geometry. So he looked at the Pythagorean theorem and then he was like, oh, shoot, let's algebraize this junk. So he came up with the distance formula. Well, he came up with the base distance formula, and then other mathematicians came with the distance formula. Why am I telling you this? Because I want you to know where the math comes from. It gives you a sort of like, whoa, like kind of step back, like, wow, it's not just here just to learn it. It's actually here because it's all around us. It actually makes sense, I hope, for once. Okay, so when I just want to share that with you. It's my passion. I love trig. And when I first learned that, it blew my freaking mind. I was like, what? I couldn't get over it for at least a week. Okay, and you know what the cool part is? I didn't even have a teacher teach it to me. I actually taught it myself. Okay, not to gloat. I don't really care about that. It's just something that, when you dig deep into something like mathematics, when you dig really deep into the roots of mathematics, you start discovering things for yourself, and it's really invigorating. It's really just powerful, and it's confidence that you get when you're just doing math. Okay, and so I hope you feel that way. It's awesome. I love it. Now, I erased everything because I want to get rid of all that. Again, this was 3, 4. This was 5. This was 3, and this was 4, right? And this is, of course, let's just say my theta. I want to calculate the trig ratios. Can we do that? Yes. The 6 trig. What sine of theta? Of course, the opposite is just 4, 5. Cosine is 3, 5. Tangent of theta is going to be 4, 3. Cosecant is 5 all over 4. And then secant is, I'm writing fast, as you can tell, right? 5 all over 3. And then cotangent, 3 all over 4. Again, something that we already know how to do, but I just wanted to show you that we can do it. Now, why does it say any angle? Because watch, we're not just going to be confined to the first quadrant now. We're not just going to be confined to just one triangle kind of out in the air, like special right triangles. We're going to be all over the quadrants. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. And we can calculate that angle now. Okay? So let's erase again. Let's go to town. What do you need to write here? Nothing. Okay? You don't need to write any of this. All right? I'm just letting you know that this is sort of what we're going to be doing. Instead of confined to the first quadrant like we usually did, where everything was positive, now stuff is going to start being negative. Okay, and that's the thing. And we're going to start getting larger angles. So this is now going to be an obtuse angle. This is a huge obtuse, whereas we usually just did acute angles. So we're going to switch from acute angles to now obtuse angles, and we're going to go to quadrant 2, quadrant 3 right here, and quadrant 4. That's really what we're going to be doing for the majority of the day. And I'm going to teach you a variety of different ways in order to do that. So let's get started. Here are your definitions of trig on any angle. What do you need to write down? Stuff that I highlight, which is specifically this. Okay? So these are the 6 trigonometric functions are defined by these ratios. Now here's the thing I need you to understand. If you don't need to write this down though, but if r equals radical x squared plus y squared, and that's the distance from 0, notice that this is the Pythagorean theorem, r squared equals x squared plus y squared, and you're like, that's not the Pythagorean theorem, it doesn't have ABC. ABC is just literally a variable. I can call it whatever I want. I can call it a unicorn, I can call it a Chevy, I can call it a cat. It doesn't matter, it's a variable. Okay, so I can change those variables, C to R, X, or A to X, and then B to Y if I want to. Why do I want to do it that way? I want to do it this way because now I'm no longer on just a single triangle. I'm putting that triangle on the XY axis. That's why. I'm putting a triangle on the XY axis, and now, since it's on the XY axis, I need to make sure I am consistent with my variables by using the variables on the XY axis, which in this case, it is, of course, X and Y, okay? So no longer are we using A and B, we're using X and Y. And then what do you think R is? R is the radius, okay? So R is going to be my radius. We're going to come back to R being the radius here. Okay, so these are what it is. Sine of theta equals y over r. Cosine of theta equals x over r. Tangent of theta equals y over x. So these ratios in the second column, of course, are just the reciprocals. So mainly these are the ones that we're going to be using. Okay, notice how this cannot equal 0 because if it equals 0 right here, the world explodes and then you don't have a tangent anymore. But luckily for us, that's not the case. Okay, so get those down. Make sure you get the reciprocals. Let's get started. Okay. Oh, by the way, before I kind of continue, why do you think that when you have r here, why doesn't it say r cannot equal 0? Why do you think that is? Well, what's r? R is the distance. Okay? The distance. So r is the distance. Can distance be 0? Well, yeah, but then would you have an angle? No, okay? You wouldn't have an angle. So that's why it doesn't say r cannot equal 0 here, because it's distance. And distance in this case is the same thing as my radius. We're going to get a little bit more into that next week. But I'm going to show you just some preliminary things this time around. Okay, how do I evaluate this? Okay, let's evaluate it. I have -3, -5 on the terminal side. I'm given a picture that looks something like this. Okay. So now notice I'm on the XY plane. The point -3, 5 is literally right here. So what I'm going to do is I'm going to plot that point, and then I'm going to kind of extend it past. So that's the point. Now watch what I'm about to do, is I'm going to actually solve this using the 6 trigonometric functions. I'm going to connect this to my x-axis. Why the x-axis? Because I said, okay, always, always, always. You do not ever, never do this. Connect to the y-axis. Never, ever. Don't do that. Do you understand me? Please don't do that. That's completely and utterly false. There's never a time where you will ever do that. You will always connect your triangle to the x-axis. Always, 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 always. You will always also have a theta right here, but we'll get into that a little bit more later. So this is -3, 5. So what's this distance here? Let's do it in a trigonometric form instead of algebra form. This distance is -3. Can you have a negative distance? Sort of. I know in algebra you probably said you can never have a negative distance. You really can't, honestly, so I'm going to say no here. But what I am saying is you go -3 units. How about that? Is that better? So -3 units, you go to the left. Okay, and then you go down -5 units. We want to find what r is right here. What is r? Let's find out. Pythagorean theorem, anybody? Yes, the Pythagorean theorem. That's my first step. So I'm going to take, in parentheses, -3 squared plus -5 squared equals r squared. Okay, now we square this is going to be 9, this is 25, this is r squared, so this is 34 equals r, and then I square root, so what is r? R is radical 34. I can't simplify that, so that's rather anticlimactic, but whatever. Okay, and then now I do my second step. My second step is to find, now that I know what r is, I can find my 6 trigonometric functions. So what is sine? Sine of theta. Do I care what theta is right now? No, I do not care what theta is right now. I just want to evaluate the function. So sine is opposite. Now where's your function at? Where's your theta? Your theta is going to be right here, attached to the x-axis. Always, always, always. It's always going to be attached to the x-axis, okay? Your theta is never going to be down here. It's always going to be right there in the middle. What is that? You're going to be opposite over hypotenuse. So opposite is -5 all over hypotenuse, radical 34. This equals -5 radical 34 all over 34. Notice how I have negatives attached now to my trig functions. Yeah, negatives attached to my trig functions because now I'm on any angle. That's the lesson, right? Any angle trig. Now I'm actually going to any angle, any quadrant. And now, because I do that, I have to attach negatives depending upon where I am in the quadrant. Cosine of theta, adjacent -3 all over radical 34. So this is -3 radical 34. And this is all over 34. Okay, and let's do tangent of theta. And then tangent of theta is opposite over hypotenuse. So this is, or sorry, opposite over adjacent. So -5 all over -3. And this is going to be 5 all over 3. For the sake of time, guys, I'll probably just keep it here. I'm not going to do my other 6. You can do the other 3 if you want to. But I'm just going to leave it right here because it's kind of redundant. It's kind of going over and over again. Just flip these, keep the negatives, you'll be fine. I promise. You know how to do it. Okay, let's move on. Let's do this example. All right, so now we're in quadrant 2. We're not going to have a picture here. So how do I do it? Well, the first step is to draw the picture. I'm in quadrant 2, so usually what I do is draw quadrant 2. Okay, this is quadrant 2, right? That's my first step. And now, watch, they didn't give me a point here, but they gave me -4 over 5, right? So I have to extend my triangle because we're in trigonometry. And then this is my theta. So this is the template. This is really the template that you're going to be using. Now, where does the 4 and where does the 5 go? Now, pay close attention. What's the ratio of cosine? Oh, that's right. Adjacent over hypotenuse. So that means the 4 is adjacent, and then the 5 is the hypotenuse. That's what it means. So adjacent right here, the attached right here is the 4. The hypotenuse is the 5. Now, I have a negative here. Where does the negative go? Can it go on the distance between here and here? No, okay, the negative has to go on the unit measure right here. So the negative is attached to the 4, not the 5. You can never, ever attach the negative to this radius, this distance right here. So what is this point? This point technically is -4, comma, something? I don't know what that something is. And that something is right here, a y. So I need to find that out. So that's going to be my second step. My second step is to do the Pythagorean theorem and find what y is. This vertical distance, this vertical unit measure. Okay, so -4 squared plus y squared equals 5 squared. By the way, you should already know what this is, so I'm just going to skip right to it. It's 3. It is a 3, 4, 5 triangle. Okay, so y equals 3. This is what x equals, and then r equals 5. My radius, my distance equals 5. This is x. This is 3. It is a 3, 4, 5 triangle. Why is it positive? Because you're going up. Why is this negative? Because you're going across into the negative quadrant. Okay. My third thing is to find my trig functions. So again, I'm only going to do the first 3. I'm not going to do the reciprocals because it's starting to get redundant. Yeah. So opposite, which is 3, and then hypotenuse 5. Cosine of theta is going to be -4 all over 5. And then tangent of theta equals opposite, which is 3, and then adjacent, which is 4. Now notice I'm going to put the negative here. You could keep the negative in the denominator, 3 all over negative 4, but it doesn't matter because it's a negative. I can put it out front, I can put it with the numerator, I can put it with the denominator, but most of the time, Math Excel will ask for it looking like this. Okay, so those are just the 3. Again, I'm not going to do the reciprocals because, again, it's kind of redundant. We already know how to do 3, 4, 5 triangles with the reciprocals. So I'm going to leave it at that. So first step, draw your picture. Make sure you kind of analyze what cosine means. It's ratio adjacent over hypotenuse. Plot it wherever you need to. The negative does not ever go with the r. It goes with the other leg. And then you use Pythagorean theorem to find this. But we knew it was a 3, 4, 5 triangle. Then my third step, actually using the trigonometric functions, the opposite over adjacent, the opposite over hypotenuse, and so forth to find your trigonometric functions. Okay, that's what we did. Awesome. Let's move on. Now, quadrantal angles. We are going to stay at this spot probably for at least 10 minutes. Okay, this slide. I'm not even lying to you. We will stay with this slide for at least 10 minutes because it's that important. I'm going to try my very best to explain quadrantal angles to you, okay? But it's going to be very tricky. So here are your quadrantal angles. You have A. 0 degrees equals 0 radians. B. You have 90 degrees equals pi over 2 radians. And then you have C, which is 180 degrees equals pi radians. And then you have D, 270 degrees equals 3 pi over 2 radians. Now remember, on our very first lesson, about a week and a half ago, I said that these were quadrantal angles. This is specific to trig, nothing that you learned in geometry. Here's the slide that we're actually going to figure out what each quadrantal angle, when attached to a trig function, when we evaluate it, what does it equal? Okay, so pay very close attention. Let's go to A first. 0 degrees or 0 radians. This 0 is 0 radians. Radians, radians, radians. The degree symbols, degrees, 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 they're all angle measures. Okay? Pay very close attention. Now, what do I have here? I have 0 degrees, 0 radians. Right here is 0 degrees or what we call 0 radians, right? That's what we have, 0 degrees or 0 radians. Does it move at all? No, it doesn't. So look at this right here. This just is straight up right here. Now, why is it starting at 1? Remember 2 days ago when I said, just cuz. What happens if our triangle, our geometric special right angles, get switched from x to 1? Remember that? So what if I had this, we had x, x, and then radical 2, and then x, and this was, 45 degrees, right? And this is right angle. That's my 45-degree triangle. What if I said that x just becomes 1, 1, 1? Remember that? Remember when I said that? You should say that. If you don't remember that, then you should probably go back and watch the video. Now's the time where I tell you it will equal 1, and why? Because your radius on your xy plane, your distance will be 1. Okay, so this distance is 1, and then obviously I don't go up at all, so it's 0. So that means your x is 1 and your y is 0, where your radius, your distance right here, watch, is 1. Now, what does that mean for us? What it means is we can start evaluating certain things. Sine of 0 radians. Sine of 0 radians. What does that equal? Sine of 0 radians equals, now watch this, y all over r. This is coming from my formula that you guys wrote down just a little bit ago, a couple slides ago. So y all over r. That was my formula for trig on any angles, right? So y all over r. Now watch. Watch, watch, watch. It's y all over r. What is my y in this picture? 0. Okay. What is my r? 1. So what is sine of 0 radians? It is literally 0. This is huge. Like Donald Trump, huge. Like it's really big. Okay, this is something that we actually need to know. So make sure you star this slide because this slide is so important because we're actually figuring out trigonometric evaluations, something that's really, really important. We found that sine of 0 radians or sine of 0 degrees, it doesn't matter, is 0. So notice how this is still my angle measure. Watch my cursor. This is my angle measure, and this right here is my evaluation. I remember when I first learned this, guys, I was like, sine of 0, 0, what the junk? It's like what the F? Like I was like, so like it doesn't make any sense because what I was confused about is the difference between an evaluation and the angle measure. The angle measure is attached to the trig function. This is radians, and then my evaluation, my side length is 0. And it should make sense that it is 0 because you're not going anywhere. You're not going anywhere at all, right? So it's 0 evaluation, 0 side length. Okay, you're not going up at all. Now let's continue. Let's continue with cosine of 0 radians. We said this was x all over r. Look back at your notes that you took earlier. Let's go a little bit faster here. Now, a little bit faster. X all over r. X is 1, so this is 1. I just got it from here. What's r? R is 1. So what is cosine of 0 radians or 0 degrees? It is 1. Now, tangent of 0 degrees. We said this was y all over x. What is y? My y is 0. Okay, what's my x? My x is 1, so this is 0. Okay? I'm not going to do the other reciprocal functions. I'm just going to leave it at that. Now let's go to my next one. Go to 90 degrees, pi over 2. We're going to do the exact same thing. Ready? So sine of pi all over 2. Sine of pi all over 2. It's y over x. I'm not going to write the formula down anymore. You can look at the formulas right here. Okay, these are the formulas. I'm going to keep those over here, and I'm not going to keep writing them down. They're right here. So I know sine is y over r, right? Y over r. What's my y now? When I actually go an angle measure of 90 degrees, my r is still 1, by the way. Okay, and this is my initial side. This is my terminal side. My r is still 1. And now I have a new point right here. My new point is not 1, 0. My new point is 0, 1. So what is my new... What's my new y? My new y is 1. My new r is, well, there's not really a new r. It still stays 1. So that means sine of pi over 2, sine of 90 degrees is 1. Try it on your calculator. Put in sine of 90 degrees, making sure you're in degree mode. What is it? It's going to give 1. Okay. Remember yesterday? Your sine must be pi over 2 because we're 1, right? Or something like that. All right. Yeah. Remember with the meme yesterday? That's where it comes from. Now you know where it comes from. Okay. So cosine of pi over 2. What is cosine of pi over 2? What is that? That's going to be x over r. So what's my x? It's 0. What's my r is 1. So this becomes 0. Okay. Now what is tangent? Tangent of pi all over 2. What is that? Tangent of pi over 2 is y over x. So my y is 1. My x is 0. And can you divide by 0? No. So this is actually really funky. It actually gives you undefined. Okay, it gives you undefined. So these boxes here are my answers for that angle measure. Now let's continue on with my next quadrantal. My next quadrantal angle is going to be pi, just straight pi, and then 180. Okay, pi 180. Now notice, okay, my point changes, my r stays the same, and so my x and y changes. And now, of course, it's just a straight line across. This is pi or 180. Now let's get to it. What is sine of pi? Sine of pi is y over r. What's my y? It is 0. And what's my r? It is 1. So this equals 0. What is cosine of pi? Cosine of pi is x over r. What's my x? Is negative 1. What's my r? Is 1. So that means it's negative 1. And then tangent. What is tangent of pi? Tangent of pi is y over x. My y is 0 in this case, and my x is -1, so it simplifies down to just 0. Awesome. Okay, let's do our last quadrantal angle. Our last quadrantal angle, which is 270. 270. What is that? Okay, so now notice my r still stays the same. It goes 270 degrees on the xy axis. And so now my, like I said, r stays the same. I have two different points for x and y. So what is sine of 3 pi all over 2? What is that? Well, sine is y over r. So what's my y? It's -1. What's my r? Is 1. So sine is -1 of 3 pi over 2. What is cosine? Cosine of 3 pi all over 2 equals, okay, that's x over r. X is 0. And then my r is 1, so this actually equals 0. And then we'll do tangent of 3 pi all over 2. This equals y over x. My y is -1. And then my x is 0. So this actually gives you undefined again. Okay, this gives you undefined because you can't divide by 0 or else the world explodes. Now, watch what I have here. This is crazy. I have all the quadrantal angles and all the trig functions, at least the trinity of trig functions, sine, cosine, and tangent, right? I have these angle measures, and I know exactly what they equal, the evaluations. I know sine of 0 degrees or 0 radians is 0, cosine of 0 degrees or 0 radians is 1. I know sine of pi is 0, tangent of pi is 0 as well. So now watch this. Okay, this is crazy. I'm going to show you something really intense, and then it's just going to be a freebie. But this is why I love trig. I'm going to do it in yellow. Okay, watch. What is r in every single case? You should say, well, Mr. Carlson, it's 1, right? Now look at my little formulas here. Y over r. Now, what if I do y over r, which in this case it's 1? So what would that make sine now? If sine of theta equals y over r, what if I put r as 1? That means it would be y over 1, which would just mean y, right? And if I did the same thing with cosine of theta, okay, this is x over r. But if I make r as 1, that means it's x all over 1, which would just make it x, right? Now watch this. Watch. You ready? This is going to blow your mind. Watch. What is tangent? In this case, tangent of theta, we said was y all over x. What is y? We said y was sine. What is x? If r is 1, we said x was cosine. So y over x, well, if y is sine, that means this equals sine of theta. And then if x is cosine, that means this equals cosine of theta. Holy junk. What did we just do? We just found y, the quotient identity of tangent of theta equals sine of theta over cosine. Why that identity is true. That to me is some of the most spectacular math. Like, honestly, I feel like a god like when I do this kind of math because it's so amazing. It just connects. All of it together is just so awesome. And it connects and it makes so much sense when you truly understand it and truly lend yourself to understand it. It's like, what? It like goes back to each lesson. Every single lesson is interconnected and it's all just intertwined and harmonious. It's just perfect. Okay, it's just perfect. This is why I love trigonometry. Isn't that amazing? That's awesome. Like, to me, that's just wow. We're going to come back to this in yellow next week, and we're going to see more connections with the quadrantal angles and the rest of the angles when we look at what we call the unit circle. Okay? So what was in yellow was a freebie, but I hope you start to see, like, whoa. I mean, I hope some of you are saying, just looking at this video, like, wow, that's pretty crazy. Like, that's intense. It all connects, and that's what I love. So let me erase this. Make sure you get all of this down here. We're going to be using it quite a bit. Let's continue with the trig table of common angles. Next week, I am going to give you, okay, and I'll say that right here. Next week, I'm going to give you what we call a trig table of common angles. I'll just move myself right there. A trig table of common angles, okay? It looks something like this, okay? It doesn't look, it's not that scary, I promise you. I'll actually teach you how to go through it. Now, if you were part of my Algebra 2.2 quarter 3 period 1, you may or may not still have something like this, okay? Which if you do, congratulations, you can use it. But I'm going to actually post on Google Classroom something that looks like this next week. And so when we go through what we call the unit circle starting next week on Monday, I will actually be going through how to fill this out. This is amazing. You can use it on your quiz, test, anything. It actually tells you all the different angles. You can just look at, your trig function, and then you can scroll over. Okay, what if I have 60 degrees or pi over 3 radians? What is that evaluation? What's that evaluation for trig? You have it right here. I'll even post the key for you so you can copy it down so you don't have to continue using it. So please, by all means, use this. By all means, use it. I will be using it because I don't have everything memorized. But until then, this is a nice thing to at least write on a note card. So let's get to it. Let's actually write them down so we have everything kind of just in one spot, okay? So we have the quadrantal angles right here. These are the quadrantal angles. We just learned them. And these are the special right angles. We learned them a couple days ago, right? So what I underlined here is the quadrantal angles. And then what I circled here is the special right angles. Now, what is sine of 0 degrees? We found that to be 0 in the last slide. What is cosine of 0 degrees? We found that to be 1. Tangent, we found that to be 0. This was 1/2. This was a special right angle. We should have these already down. So I'm just going to fill them out for you. And then this was radical 2. You can fill it out with me. This is radical 2 all over 2. This is radical 2 all over 2. This is 1. We found this to be radical 3 all over 2. We found this to be 1 over 2. And we found this to be radical 3. Quadrantal angles from the last slide, we found this to be 1, 0, and then actually undefined, which I'll show you next week why that is. And then we found this to be 0, -1, 0, -1, 0, also undefined here. Okay, so please fill this out to the best of your ability. This is an amazing just trig table of common angles. I'll give this to you, a more elaborate version of this, but for right now, during your quiz and everything, you can use this. Okay, I hope you're not freaking out too much. I hope you're really not freaking out. Pause the video if you need to and take a break. Go use the restroom. Go talk with your friends. Go Snapchat. Play a game. Drink some coffee, whatever. All right, signs of trigonometric functions. Signs of trigonometric functions. What is this? I'll let you read as I take a drink. How about that? Depending on where the point P lies, the signs of the trig functions change. It could either be negative or positive. Now, we kind of already knew this. When we did the trigon and the angle and I gave you a point, you could see that the cosine and the tangent and the sine were starting to introduce negatives, and some of them are negatives and some of them are positives. There's a reason why that is the case, and I'm going to show you what that is, okay? So a helpful tip to remember where trig functions are either positive or where trig functions are either negative is to remember the limerick, all students take calculus. I wish that were true. That would be amazing. But it's just not true. Okay, so all students take calculus. So I'm going to kind of explain this real quick for you. All, right here, quadrant 1, all. So this right here is quadrant 1. All students sine, so this is quadrant 2, take tangent, so this is quadrant 3, Roman numerals, calculus, cosine, so this is cosine, this is quadrant 4. Okay, all students take calculus. All students take calculus, all sine, tangent, cosine. So what does this mean? That means all trig functions are positive in the first quadrant. Obviously, everything is freaking positive in the first quadrant. You're like, tell me something I don't know, Mr. Carlson. Come on. I will eventually. Just give me a second. Okay, so all trig functions are positive here. All sine functions, including cosecant, it's reciprocal, are positive in the quadrant 2. That means all other trig functions are negative, okay, are negative in the second quadrant. Now, all tangents and all reciprocal of the tangent, the cotangents, are positive in the third quadrant, which means everything else is negative. And then cosine is only positive in the fourth quadrant here, whereas everything else is negative. Okay? So the reciprocals kind of go with it, but this is helpful. All students take calculus. Now, oftentimes you'll see me write this, and I'll literally do this in the next slide. I'll say, okay, kind of determine which trig function is negative in which quadrant or which trig function is positive in the next quadrant. I'll write this: a plus, s plus, t plus, and then c plus. And then we'll start kind of deducing by deduction, by math and deduction, just seeing which quadrant are we in. But I'll often write this. So let's get to it. I'll show you our example. So finding the signs of a trig function. What are the signs of a trig function? How can I do that? Now watch. If I'm given tangent is less than 0 and cosine is greater than 0, name the quadrant. I'm not solving for anything. I just want to name the quadrant. So my first step is this. Okay? My first step is really to find what is this? Like, what is this? Is this negative or positive? If I say something is less than 0, is that going to be positive 1, positive 2, positive 3, positive 4? No. If it's less than 0, it's negative. If it's greater than 0, that does mean it is positive. So what does this mean? Tangent is negative, cosine is positive. What are we going to do? Now watch. Let's do all students take calculus. Now watch what I'm about to do here. I'm going to start deducing. If I have, in this problem, a negative tangent, will I be in the first quadrant? No, because all functions, including tangent, are positive in the first quadrant. So I can't be in the first quadrant. Okay? Now, if I have a negative tangent, does that mean I can be in the third quadrant? Again, no, because tangent must be positive in the third quadrant, but it's saying, this problem is saying I have a negative tangent. So that means I can't be in the third quadrant. Now, that leaves the second quadrant and the fourth quadrant. Now watch. If cosine is positive in this problem, that means I must be in a quadrant where only cosine is positive. But it can't be in the second quadrant because only sine functions are positive in the second quadrant. And that means cosine would be negative in the second quadrant. So that means it can't be in this quadrant, and it has to be here because that makes cosine positive. So this quadrant, quadrant 4, is my answer because tangent is negative in quadrant 4, but also at the same time cosine is positive in quadrant 4. So I didn't solve anything here. I'm just kind of getting used to where my trig functions are negative or positive. That's what I'm doing in this example. Okay? Now what about this example here? I'm giving a little bit more details. Giving tangent equals negative, cosine equals or cosine is greater than 0. So let's find out. My first step is this. All students take calculus. Now, similar than this, okay, negative is with the tangent, and then the positive is with the cotangent. So that, or sorry, the cosine. So that means it's literally the exact same thing, the same quadrant. That means I'm not going to be here because I have a negative. I'm not going to be here because, again, tangent's negative. I'm not going to be here because cosine is positive, and cosine would be negative in the second quadrant. And so that means I'm in quadrant 4, just like what I said. Now, let's go on to my next step. My next step is to figure out, all right, I know I'm in the fourth quadrant, so I'm going to draw my fourth quadrant. Okay, I'm going to draw my extending triangle, just like what I did before. This is my right angle attached to the positive x-axis here. Yes, always attached to the x-axis, never right there. Okay, now what am I looking at? Well, what's the ratio of tangent? The ratio of tangents is opposite over adjacent. So opposite 2, and then adjacent is 3. Now, which one gets the negative? Because I need to put the negative somewhere. Well, think about it. If this is a point, guys, this is a point, and then 3, and then 2, which one gets a negative, the 3 or the 2? I go over 3, and the positive side, I go down 2, so that means the 2 must get the negative, and so I put a negative here. What does that mean for r? What is r? Let's find out. And that's my third step. My third step is to now find out what r is. So I do the Pythagorean theorem. And then plus, and then negative 2 squared equals r squared. This is 9. This is plus 4 equals r squared. This will be 13, so that means r is radical 13. So I'm going to put that right here. R is radical 13. Boom. And now I want to find just 2, cosine and cosecant. So my next, not my third step, I already did my third step. Silly Mr. Carlson. Steps are for kids. Okay, my fourth step. Okay, so cosine. What is cosine of theta? Do I care about what theta is? No, I don't care about what theta. We will shortly in this lesson, but not right now. So theta right now is adjacent over hypotenuse, so that's 3 all over radical 13, which reduces down to 3 radical 13 all over 13. So I have cosine there, and then I also want to find cosecant. So cosecant is hypotenuse all over opposite, because it's a reciprocal of sine. So cosecant is hypotenuse all over opposite. So hypotenuse is radical 13 all over the opposite of sine of theta, or all over the opposite of theta, which is just negative 2. And I'm going to put the negative just out front. It doesn't matter where you put the negative. I'm just going to put it out front. Make sure you get that negative here. Okay? And those are my 2 answers. Awesome. So that is how you evaluate trig functions literally on any angle. Okay? Even in the quadrants. So get that down. Let's erase. Checkpoint. Fantastic. Let's go through the checkpoint. See if you can name the quadrants and then find this out. I'm going to go through this fast. Go ahead, pause the video. I'm going to do the answers. I'm going to briefly explain them and then we'll move on, okay? So check to see if you understand. Awesome. Welcome back. So now here are the answers. So this first checkpoint to checkpoint 3, I just need to do all students take calculus. I understand that sine is negative, cosine is positive. So I have to deduce what that is. It can't be the first quadrant because we have a negative. It can't be sine right here because sine is only positive and sine is negative. And it can't be quadrant 3 tangents because I look at cosine and that's positive and cosine would be negative here, which means I have to do the quadrant 4. So I go down, I write my quadrant 4 because that's also the same thing. I have tangent as negative. Yeah, so I know it's quadrant 4 because tangent is negative and cosine here is positive. So I know that it is quadrant 4. So I start writing my quadrant 4 right here. And then I look at, I draw my 3 and my negative 1 because tangent's negative 1/3 and tangent's opposite over adjacent. So opposite negative 1 over adjacent. Why is it negative? Because you're going down instead of right. So it's going down right here. This point right here is 3 comma negative 1. That's that point. I do Pythagorean theorem to find my r. R is radical 10. And then I want to find just sine and secant. So I do opposite over hypotenuse. Opposite over hypotenuse is negative 1 all over radical 10. I rationalize, so I get negative radical 10 all over 10. Secant is going to be hypotenuse all over adjacent. So hypotenuse is radical 10 all over adjacent, which is 3. It should not surprise you that secant is positive because you're in the 4th quadrant and its reciprocal cosine is also positive. And it shouldn't surprise you that sine here is negative because only sine is positive in the 2nd and 1st quadrants. But right now we're in the 4th quadrant, which means sine would be negative. Okay? Awesome. If you got those answers, you're fantastic. Let's move on here. Reference angles. This is the last thing that we're going to be doing in this lesson, reference angles. Reference angles can be tricky, especially because the book and Math Excel just explain it so junkily. It can be tricky, but it doesn't need to be tricky, okay? So reference angles, it will basically be a non-acute angle in standard position that lies in a quadrant. So it's reference angle then, okay? It's reference angle. For that non-acute angle, that means non-acute is just straight obtuse. So when you have a huge obtuse angle, and I'll show you, when you have a huge obtuse angle like this, okay, this theta right here, this whole thing, that's a theta, that's an obtuse angle. What is your reference angle? Your reference angle is then this little angle right here, this little thing. That's your reference angle, okay? Why is that needed? Because it helps us evaluate certain things. Now, you can find what the reference angle is, but if a reference angle is, let's just say, a special right angle, which means if my reference angle is like pi over 3, we already know what sine of pi over 3 is, tangent pi over 3 is, cosine of pi over 3 is, because we have those in our notes. We have written them down on the trig table of common angles, what you have, just a little bit ago, actually. So we already know what this stuff is. What if I have a reference angle of 40? Can I evaluate that? No, I can't, because I don't know what tangent of 40 degrees is. At least I don't know what tangent of 40 degrees is as an exact measurement. I know what the decimal version is. I can just plug it into Desmos, right? But I don't know what the exact measurement is. So when we go through reference angles, I need to know what the exact measurement, the exact actual value is in order to calculate the reference angle. Otherwise, I just am going to be asked to find what the reference angle is. Again, what is a reference angle? If I have this blue angle right here, my reference angle is what's in red, the thing that's between the x-axis and then the actual angle itself. It's that little thing, okay? Now, I really don't like how Math Excel explains it. This also explains it a little bit better. I did a really junky one right here, but I really don't like how Math Excel explains it. And with that said, maybe some of you do. I'm going to give you 2 slides. First, I'm going to give you a slide, go through another examples, some examples, then I'm going to give you another slide, and then go through another examples. Those 2 slides, though, will give you the steps to how to calculate reference angles, how to calculate exact values. I don't like those steps. I'll be very honest with you, okay? I will skip past them pretty much, but if you want to write them down, you can. You don't need to write this down. This is kind of like gibberish, but really what it's saying is your reference angle is the theta prime right here. So this is a non-acute. This is a non-acute angle right here. Your theta prime is the thing that's in between your positive x-axis and right there, the positive x-axis right there, the positive x-axis right here, and so forth, okay? So that is your reference angle. Let's continue. You don't really need to know that. Here's the steps. Again, you can write it down. I hate these steps. It's so intuitive. Like when I actually do the reference angle, students just know what to do once I show them. It may sound counterintuitive when I show you the steps of how to do a reference angle. You actually, most students at least, in my experience, most students get confused. So I usually don't like showing the steps, but by all means, you can pause the video and write down the steps if you are that kind of person that like really likes steps. Go for it. But I'm telling you, in my experience, most students get confused with these steps. So I usually just don't show them. Let's find the reference angles. Now notice it's not asking to evaluate anything. It's not asking for the side length. It's asking for the angle. Okay? It's asking for the angle. It's find the angle. Find the reference angle. So what does that mean? I'll show you what it means. I'll show you an easy way to do each of these. Okay? So A, what is 345? Ready? What I usually do is I always plot it. Okay, I always plot it. And I literally just kind of go, okay, where's 345? I know 345 is going to be in the 4th quadrant. Why? Because if I go the whole way, it's 360. But I don't go the whole way. So this is 360, right? If I went the whole way, it's 360. But this is 345. I don't go the whole way. So what is this little angle right here in between? That little angle is the difference between the full revolution and then what I actually stop with, which of course in this case it is just 15. Okay, so what is my reference angle? My reference angle is 15 here, theta prime. Make sense? I hope that makes sense. Okay, awesome. Let's go to this one, blue. What is my reference angle? Again, I'm going to actually plot it. You can change it to degrees if you want. I'm not going to. Now watch what I'm about to do here. I'm going to actually keep it in radians. This may confuse you, just saying, but I'm going to keep it in radians. This is what it's saying is 5 pi all over 6s. That's what it's saying. 5 pi all over 6s. So that means I can literally count the pi over 6s on my graph. So this is pi over 6, and then which is 30 degrees, and then if I add another 30 degrees, I get 60, and then if I add another 30 degrees, I get 90. So that means it looks something like this, right? I have like 2 of these just chilling. Kind of looks like this, like a spider web. Now watch what I'm about to do here. Ready? So this is 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. So that means my obtuse angle is this one right here. This is what we call 5 pi over 6. So what we want to know is, what is this? What is this angle? This angle is, again, just pi over 6. Why is it pi over 6? Because if I go another pi over 6, this would equal 6 pi over 6. And if I go 6 pi over 6, what would that equal? If I did another angle, 6 pi over 6, it would be a straight line. What does 6 pi over 6 reduce down to? Oh yeah, pi, which is 180, which gives me the straight line. Okay, so that means my reference angle here is just pi all over 6. Because it's that little thing in between this x-axis right here, this x-axis, and my obtuse angle. Because this is what 5 pi over 6 looks like, this whole thing. I counted. And then this little thing in between the x-axis and that angle is my reference angle. I use it for a reference angle. The reason why I say a reference angle is because I use it as a reference in order to evaluate what my trig function is. But in this case, we're just finding angles. We're not evaluating anything. Okay? Okay. Let's go to this one. C, negative 135. Let's see what that looks like. It's negative, so I'm going to go around. And it's actually going to be somewhere right here. Now, why is it going to be right here? Because I know if I go negative, this is 90 degrees. And if I go another 90 degrees, this is 180. But I don't want to get to 180 because that's too far, right? So I know it's in between this and the third quadrant, negative side. This is positive, this is negative. Now watch right here. What is this angle? If this is negative 135, okay, if that's negative 135, what is this, right? Like, what is this? Like, what is this little theta prime here? What is that? How can I get from negative 135 to here, negative 180? I know this is negative 180. So I just subtract them. Really, I basically just find the difference. And so the difference is actually just 45. Okay, so this is actually just 45 degrees. Okay, yes, 45, I think. Yeah, definitely 45, right? So that is my reference angle, 45 degrees. The thing in between your obtuse angle and the positive or negative x-axis. Okay, now this next one, let's do purple. This next one's a little bit tricky because it gives you it in radians and it's a decimal in radians. So the first thing I would actually do is get rid of this junk. Get it in degrees, personally. Because it's really hard to try to figure out what this is in radian mode. So I'm actually going to multiply this 2.5 times 180 and then divide it by pi. What is that in degrees? Let's go to Desmos to find out. Okay, so it's going to be 2.5 and then times 180 and then divided by pi. Make sure we're in radian mode. So I'm in radians because I was given a radian, right? So that means this is my degrees. I was given a radians, okay? I was given a radian mode, yes? So I was given radians, and then I need to change it to cancel and to convert. So I'm given 1 143.2. Let's just do that, 143.2. So let's do it on this because I don't want to go back to the other slide. So right here, 143 is actually like somewhere right here. So this is 143.2 degrees. So what is this? Theta prime. What is that? What is this? If this is 180 degrees, that's all I need to do, right? 180 degrees, subtract that by that. Yes? So watch what I could do here. This is awesome. If you ever use Desmos, I can label this A equals. Watch what I'm about to do here. Okay? Wow, that's really unfortunate. I'm so sorry. Okay, I'm actually going to take 180 degrees minus A, and it gives me that. The reason why I do that is so I can get an exact measurement. And so this right here is a little, I know, this just looks awful. I'm so sorry. But this is what it looks like. And so this right here is my reference angle. This is the thing that if I go 143, so this is 143.2, this right here, theta prime, is 36.76 degrees. Now, since it gave it to me in radians, guess what I must do? I need to change it back. Okay, so I need to actually change it back. So I'm going to take this. Let's just label this as B. I want the exact measurement, right? So let's just label B times, let's change it back to, because it's in degrees, I want to change it back into radians, right? So that means I take B times, in radian mode, pi divided by 180. And then make sure I go back over here and I need to change to degrees. And this right here is my answer. Okay, this is what it is in radian mode. That was a little complicated. Okay, a little complicated, but we got the right answer. All right, that's the reference angle. Okay. All right, let's continue on. Let's erase this. Now let's find more reference angles here. So I'm going to go and just do these really, really fast, okay? 580, what is 580? Well, 580 is going to be a full 360 degrees, yes? And then another 180 degrees, because 360 degrees plus another 180 degrees is definitely not past 580, okay? But then I go a little bit more, and then I finally get to 580 degrees, okay? So again, this is 360. When I go the full revolution, I go plus another 180 degrees, which would be, what, 440, I think? 540, it's 540, right? So this is 540 right here, and then I need to go just a little bit more to get to 580. So what does that mean my reference angle is? This thing right here. How can I get from 540 to 580? Well, of course, my angle, my reference angle, theta prime, is just 40 degrees. Okay? Pi over 3, let's do that. Pi over 3, I'm going to actually count. What is pi over 3? You can change it into radians if you want, but this is saying 8 pi over, or sorry, change it in degrees if you want. This is saying 8 pi over 3s. Okay, what that actually means in degrees is just 120. Okay, I'm going to keep it in radians though. So this is pi over 3, this is pi over 3, and this is pi over 3. It looks something like that, roughly. So right here, this is 1 pi over 3. This whole area is 2 pi over 3. Okay. Sorry. This is actually 480. This is 2 pi over 3. This right here would be 3 pi over 3. This is 4 pi over 3, 5 pi over 3, 6 pi over 3, and then this is another 7 pi over 3, and this is 8 pi over 3. Now, if you don't understand that, by all means, don't follow along. This would be 8 pi over 3. I don't want to confuse you. So if you don't understand that at all, then just switch it to degrees, and it's going to be 480. Okay? It's going to be 480. So this is 8 pi over 3 or 480. Now, what is this little guy right here? How can I get from right here to here? All I have to do is essentially take this minus pi. Okay, so this is pi. So I take 8 pi all over 3 and then minus 2 pi, not, because I went around the full thing, right, at least once. So I went around like this to get here. So I need to subtract by 2 pi. When I subtract by 2 pi, I actually get, I'm not going to show you the math here, but I actually get 120 degrees. So 120 degrees, which is this little guy right here. So once I do that, I get 120. 120 degrees is this guy right here. Okay, in blue. Maybe I'll put it in purple because there's a lot of stuff happening here. So I'll put it in purple. So this purple is 120 degrees, or what we call 2 pi all over 3. That's 2 pi all over 3. And then so really what I need to do, and this is what I get. So this is 2 pi all over 3. Okay. But that's not my reference angle. My reference angle is what's in between. So I take 2 pi all over 3 and then minus, or sorry, I take pi right here and then minus 2 pi all over 3. And then I get pi all over 6. This is my reference angle. That one was really complicated. I get that because it's really just in radians. Honestly, most of you are going to probably just switch it to degrees. Seriously. Most of you are just going to switch it to degrees. Do that. What's the difference here? It's way easier than sticking with these radian modes. Okay? Go ahead and actually do C by yourself. Pause the video. Try to do C by yourself. I'm going to pull up the answer, and so hopefully you get it right. Awesome. So this is your answer. You get right here, it is actually just negative 390. You go all the way around the negative route. So you go a little bit more past negative 360 to get to what we call negative 390 here. And the little more that you did was just 30 degrees, negative 30 degrees. And then we translate that 30 degrees back into, you translate that 30 degrees back into radians. Now, two things here. Number one, reference angles can never be negative, so you can't do negative reference angles, okay? So it always has to be positive. And number two, I messed up on the other one. So I saw that when I was kind of doing it. It's not pi over 6, it's pi over 3, okay? So if you have questions on this one, by all means, I kind of butchered this a lot, so I apologize. It's a lot, it's really busy. So if you have questions on that, let me know. I promise you, not all of them are that hard, but I'm going to erase. And now we're going to get to checkpoints. Try to do these by yourself as much as possible. I'm going to try to just basically pull up the answers. If you feel like you had them, then let me know. Or let me know if you got it. But I'm not going to do a lot of the work on some of them. But just if you feel like you got it, then awesome. So go ahead and pause the video. All right. So here are the answers for checkpoint 5, 30 degrees, pi over 4, 60, and then 0.46. If you have any questions on these at all, just please let me know. I can work through them with you. I know these are the answers, and I'm just giving you the answers. I don't really show you how I do them, but if you got something similar to that, at least you know you're on the right track. 665 was a little bit complicated. I actually did show you how to do that because you had to go all the way around. So you had to go all the way around 360, and then another 180 to get to 540, another 90 to get to 630, and then a little bit more, 35 degrees. This was 35 degrees right here to get to 665, which is what you want. And then what is left over underneath this 90 degrees right here, what was left over is 55 degrees. Pi over 4 is the reference angle for this one because you just count over and over and over again. So you split it up, each one into halves. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 pi over 4s. And then so it goes all the way around here. And then, of course, the other half is pi over 4. And then here, the reference angle is pi over 3, almost exactly just like this one. You notice that this is like a negative 11 pi over 3s, or 15 pi over 4s. So really what this is just our reference angle. We can take this thing out and just add it to that and just make sure we have it. Okay, if you don't understand that, by all means, email me. This is really hard math. I'm not going to lie. Reference angles is just hard to teach in general. Okay, it's very difficult to teach because it's very analytical. Okay, so if you have any questions, please email me. Let me know. I'm going to erase. All right, here are the steps. You can actually write this down if you want. Again, I don't really like these steps. Okay, so I'm just going to pause. You can pause it if you want, but I'm telling you, I'm not going to go through these steps. Now we're actually going to evaluate. Okay, here's what we're going to be doing. We're actually going to evaluate the trig functions. Before we were just finding reference angles, but now we're actually going to evaluate them. Let's get started on what they are. Okay. So what is sine of 135? So if I span this out, sine of 135 is roughly right here. This is 135. Okay, so this is 135. And then what is this little area right here? What is that? Okay, that difference here. Okay, and we know that this is 180, right? So what is this little difference here that I haven't gone to? Well, we take 180, subtract 135, and this actually equals 45. So that means this angle right here is 45 degrees. So angle is 145 degrees. That's my reference angle. Now, what we can do is then say, okay, if that's my reference angle, this is my triangle. I'm going to blow up this right here. And I know that this right here is 45 degrees. And so that means it's my special right triangle, right? I can do my special right triangle. So this is 1, this is -1, and this is actually radical 2 here, okay? This is my special right triangle. I can do that because that's always the same thing. And so what is sine of this special right triangle if it's 45 degrees, my reference angle? Well, it's opposite over hypotenuse, which is radical 2. So this is 1 all over radical 2, which of course is radical 2 all over 2. Boom. Okay? Awesome. And if you knew what sine of 45 degrees is already, it's clearly radical 2 over 2. You have that in your notes. You have that in your trig table. So please make sure just to know that sine of 45 degrees is radical 2 all over 2. Same thing here. Let's go to town on this. So what is pi over 4? What is that? Well, 4 pi all over 3 is just going to be 240. So 4 pi all over 3 is 240. You can change it into degrees if you want. So it is 240. So that means it's going to go all the way around and it's going to stop right here. Okay. Remember, this is 270 and then this is 180. And then this angle right here is our 240 degrees, or 240 degrees. So what we want to know is what's in between here. Remember, we're going to the positive x-axis, right? And this is my right angle. So what is in between here? What is this theta? This theta right here. How do I get from 240 to 180? Well, I subtract. So that's actually 60 degrees. So that means my reference angle is 60 degrees, or pi all over 3. Which means what we can actually calculate is cosine of just pi all over 3, which you guys should already know, and then this is 1/2. Okay? That's 1/2. Sweet. So now we can do this cotangent. If I go underneath, so pi over 3, which is just 60 degrees. If I go underneath pi over 3, it really is just pi over 3. So this is, yes, this is 60 degrees. Okay, that's pi over 3. So really what I'm trying to find is just cotangent of pi over 3. Okay, what is cotangent pi over 3? Well, I know, it's the reciprocal of tangent, and I basically can build my triangle, or I can look at my notes, basically. I'm going to build my triangle. I know that this is pi over 3 here. Okay, pi over 3. This is going to be radical 3 all across, and since it's down, it's negative. So make sure since it's down, it's negative. Just like this was across and it was negative. This is down and it's negative. This is 1, this is 2. Cotangent is going to be adjacent all over opposite. So adjacent, which is 1, all over opposite, which is negative radical 3. So this is actually negative radical 3 all over 3. This is my reference angle evaluation. my reference angle evaluation. So I'm not just solving for the reference angle, I'm also going a step further and solving for what it actually equals. So these are why it's called a reference angle, because you're using that angle to reference the triangle right here, your special right triangles. Remember, if you don't know your special right triangles, this is going to be one chunk of a time. I'm telling you, it's going to be very difficult for you to it's going to be very difficult for you to actually solve these problems if we don't know our special right triangles, or at least don't have them memorized, what cotangent and pi over 3 is. This is also in your notes. Okay, but the reason why it's negative, and this is the important part, the reason why it's negative is because it's in the fourth quadrant. Actually, go back. This is actually negative too. I know that this is negative because it's in the third quadrant, and only cosine is positive in the fourth and first quadrant. So that means it must be negative, because if this right here is 60 degrees, pi over 3, that means this is also negative radical 3. This is negative 1, and this is 2. So adjacent right here over hypotenuse. Sorry, that was definitely negative 1/2. So be very cautious. Even me right now, I've kind of skipped over, okay, this. Now, why was this positive here? Why was this positive? Because this is the second quadrant, and sine is positive in the second quadrant, right? Okay, and that's what I have here. Sine is positive in the second quadrant. So build your triangles here. Use them to your ability, but we can use it to reference our special right angles, and that's the purpose of reference angles. This is a hard lesson. I'm not going to lie, guys. This is very difficult. So if you need any help at all, please, please, please let me know. Okay? Please, please, please let me know. Replay this video. If not, use the videos on Google Classroom. I'm going to erase. And then you can use this checkpoint here to check your math. So go ahead, pause the video, do one last checkpoint before we wrap up. All right, so this is all the work laid out for you. I'm going to briefly explain it, but I have to emphasize the importance of your triangles, your special right triangles, using in these references. Okay, so sine of 300 goes all the way over here. It's past 270, but it's before 360. And so basically, it's right here, 300. In order to get up here, okay, I have to go to another 60 degrees. So that's my reference angle, 60 degrees, which means I'm going to build my special right triangles as such. The opposite of 60 degrees is radical 3. This is 1, this is 2. And notice how I'm putting a negative here because it's negative going down. So using that, I basically go to sine of 300, so it's opposites over hypotenuse, so negative radical 3 over 2. Notice I'm in the fourth quadrant. Only cosine is positive in the fourth quadrant, which means sine would be negative in the fourth quadrant, and yes, it is negative. Tangent of 5 pi over 4, I kept it in radians, so I counted 1, 2, 3, 4, 5, and so it's right here. It goes all the way around like that, and then that is my actual angle here, okay? And then I build my triangle, but I build my 45 pi over 4 triangle because this is pi, that's 5 pi over 4, and I know that this is in the middle, and so that's half of 90 degrees, because this whole thing is 90 degrees. That's half of 90 degrees, and half of 90 degrees, or pi over 2, is pi over 4. So I know my reference angle is pi over 4. Since it's in the third quadrant, both of it gets negative, negative 1, radical 2. Again, that's my special right triangle. Since that's my special right triangle, I look at my tangent 5 pi over 4 again. I go opposite over adjacent, so negative 1 all over negative 1 equals 1. Now I go to secant pi over 6. I go down, and so it's really easy. It's just right there, which means my reference angle is, of course, pi over 6. So since my reference angle is pi over 6, I look at my special right triangle, and that is negative 1, radical 3, and 2. I have a negative 1 right here because it's going down, right? And then my secant is actually adjacent, or hypotenuse all over adjacent. So my hypotenuse 2 all over adjacent, radical 3, rationalize 2 times radical 3 over 3. Notice how this is positive because we're in the fourth quadrant, and cosine functions, including the reciprocal, which is secant, is positive in the fourth quadrant. Okay, now I went through that really, really fast. I'm going to erase. And again, guys, if you have any other questions, by all means, let me know, okay? If you have any other questions, you need to let me know. This was a rather complicated, a long, complicated video, but I hope we can get through it. I really do. Let me know before you take your quiz. We use the definitions of trigonometric functions of any angle. We started with that. We also use the signs of trigonometric functions. We found out what reference angles are, and we definitely use them. We also use reference angles specifically, not just to find the angle, but also to evaluate trigonometric functions, which is probably the hardest part of the lesson there. All right. Now, we did do it. I'm so happy that we actually finished it. Because of the lengthiness of this video, because of the difficulty of this lesson, here's what I'm going to do. You do still have a basic trig functions quiz because it's so foundational. We need to know this foundational stuff. I usually don't, but I will allow up to 5 extra credit points on the regular homework assignment, the trig functions on any angle, and I will allow up to 5 extra credit points on the quiz review. So if you complete the regular homework assignment and the regular quiz review, or just the regular homework assignment and the quiz review, both at 100%, I will give you up to 5 extra credit points on each. So if you complete both of them at 100%, you can get up to 10 extra credit points on your quiz. 10 extra credit points on your quiz, which means that's literally equivalent to 20% extra credit points. It's 20%. So if you got an 80 on the quiz when you take it, and if you did both of them at 100%, congratulations, you just got 100%, okay? So I'm going to do that because, again, the nature of this video, the nature of the math, it's actually very difficult. It's kind of strenuous. So please feel free to utilize that. If you have any questions on that policy, just let me know. But I look forward to hearing your questions. I look forward to seeing you guys struggle, really good struggle, a good struggle, not an unhealthy struggle, but a healthy struggle with the mathematics. Okay, watch the video for tomorrow. I'm going to go over some Bell work questions so that you're adequately prepared for the actual basic trig functions quiz. But until then, I'll see you guys. This is C Squared Mathematics. Make sure you like and subscribe. Peace.